Hello and welcome back. Today we are going to be talking about the physics of biking. So there's three things that I want to talk about today. The first thing is torque. The second thing is aerodynamics, and the third thing is the wheels, okay? So let's get started with torque. So what is torque? Torque is a measure of the turning force of an object. And in the bike, you can see it's the crank. So I'm going to be showing you what torque is, and thank you for my father for helping me. So when you're pushing down here, you are applying torque, and torque is power. And cyclists want more torque because you want more power if you want to go faster. So when you're pushing down here, you're applying torque. But when you're pulling up here, if you're just wearing a regular shoe, you can't really pull up. So you're losing like 50% of your torque by this. But the torque is going down like this. The formula for torque is the length of the lever times the magnitude of the force. So to make the torque increase, you could either increase this lever, which is basically impossible to do because this is like built in unless you have another pedal or whatever, or to maximize your torque. And you can do that by what I'm about to show you right now. So this is our indoor Peloton, and you can see this shoe is clipped in here. So when you're riding, you're applying torque as you go down like normally, but then when you're pulling up, you can pull up on this too. So when you're pulling up, that's also applying torque. So if you have shoes that can clip in, I don't for the normal bike, but on here you do. That's why you have more torque on like a bike that has clips like this, because you can apply torque all the way around, and that makes more power. So just to summarize what we learned about torque, cyclists want more torque because that gives you more power, and therefore you need less energy to achieve a certain speed. And the ways to do that is to increase the length of the crank, which is the pedal thingy, or have clips in so your torque can go all the way around, and you can have torque going all the way around and not just when you push up, because you can't do that with normal running shoes. The next thing I want to talk about is aerodynamics. So when you're biking, here are the forces that are acting upon you. Okay, the force of gravity, which is making you go down, the force applied, which is making you go in the direction you're going, and there's like two kind of resistance forces. The force of friction on the ground and the force of air resistance, like coming at you. And that's the main thing we want to talk about, because as you increase your speed, the force of air resistance increases. And you want to go faster, or most people want to go faster, and to go faster you need to decrease your air resistance. And to do that, to decrease the air resistance, you need to decrease your surface area. So here's how bikers do it. This is what it looks like when you're sitting on my bike, which is just a normal bike. It's a hybrid. So when I'm biking, I'm sitting kind of upwards like this, my arms are slightly bent, and all this wind is coming straight at me. So I have a lot of air resistance right now. So if I want to decrease my air resistance, I have to bend down and so because then I have less surface area like this way. So the air resistance is only coming on here as opposed to all of this. But my bike isn't really meant for going fast. Like I said, it's just for like riding around. And then I'll show you, let me just put it like that. Okay, and I'll show you what one of my dad's bikes look like. Oh, I need the key. Okay, I'll pause 1 second. So this is one of my dad's bike. As you can see, the handles are different than mine. So this allows you to like hold on like this so you can bend over easily without really hurting your back. And it just makes you go faster. And also you can see his bike here has, it's okay, don't worry, it's fine. Oh, good. So as you can see, his bike also has clips so he can maximize torque all the way around. Yeah. So to summarize, one of the best ways to go faster is to decrease air resistance, and to do that, you have to decrease your surface area, and that's why you want to like crunch down. And it's also kind of the same with swimming. Like when you're swimming, you don't want to be like, oh, so big. You just want to be like a streamline. That's like in streamline. You're not like, you're just like a little line. And that's with a lot of sports, like basically all sports have to do with speed. Also, another thing I remembered about the streamline thing, like the minimizing surface area, is like also race cars. That's why they're really low to the ground, and they're really like, so they so they don't take up a lot of air in this direction. Wait, that made no sense whatsoever. They just they're just minimizing surface area. The final thing I want to talk about today is wheels. So the heavier, like the greater the mass of a wheel, those are more for mountain bikes. That means the more torque is required to reach a certain speed. Also, the bigger the mass, the higher rotational inertia. So inertia is, I talked about this before, but inertia is like something's resistance to change. So if something is moving at a constant velocity or standing still, they will keep doing that unless there's another force that is applied, like an outside force. So higher rotational inertia, to be honest, I'm not like 100% about what that is, but that's just like resisting change. So it's harder for wheels that are bigger to become faster. So I'll just show you some different wheels right now. So we don't really have like a mountain bike. This is also kind of a hybrid, but this is another, my dad's bike. But this wheel you can see it's bigger than this wheel. This wheel is a speed wheel. It's going for really fast because it's heavier and it has bigger mass, so it's harder for someone to speed up. But this one, it's easier. That's why you see like all those really fast cyclists, their bikes are super skinny and they also have these handles right here. So they can just go and go really, really fast. So another thing that I found out when I was researching for this video was that there's some wheels that are also like racing wheels, but they are like, for example, this is just all one. I'll show a picture of it. I don't have it, but I'll put it in this video. This is all one. And so although the mass of that wheel is slightly bigger than another racing wheel, that wheel can still go faster and have smaller rotational inertia, because I'll insert the equations right here. There's a lot of complicated equations that I'm not going to get really into, but this is, yeah. Because different distributions of mass of wheels affects rotational inertia in different ways. So to summarize wheels, if you want to go fast, you want to have the smallest rotational inertia possible, because that makes you have you need less energy to get to a certain speed. And then but that doesn't just mean you should always have really skinny wheels, because if you're going mountain biking, you need thicker wheels or else you're going to fall everywhere. I hope you had fun learning about, this reflection scared me. I hope you had fun learning about bikes and the physics today of bikes. And you should go biking. If you have a bike, you should just go biking. It's really fun. You don't need to be with a lot of people because we're physical distancing. And it's really fun. But yesterday I was on a bike and I did this in my hand. I covered it with a band-aid though. I was biking on like gravel with those little rocks in the road, and then I just went, I think I turned too fast. I don't really know what happened. I was just, oh, and then my bike slid for like a meter, and then I'm fine. And I also kind of hurt my hip. Not hurt my hip, it was just a little scratch, but thankfully I was wearing leggings. If I was wearing shorts, it would have been a lot worse, but that's fine. It happens to everyone falls. And so it's just fine, you know, just go biking. It's really fun. Yep. That's all for today. Thanks for watching. Goodbye.